guys, remember, think about back to college prep math. A lot of college prep math was spent on saying, here's a function. How do you vertically stretch it so many units, or shift it to the right, or maybe move it up or down, reflect over the x-axis, y-axis, or maybe there's horizontal. You ever talking those terms at least? You ever talking about those types of terms? Okay. Well, that's a lot of what today is going to be, where it says 1.8 is titled New Functions from Old. Who would volunteer to read this essential question for me?
How are functions transformed, and what effects do changing variables have on original functions?
We're really going to talk about transforming functions, okay? Transforming meaning what? Moving it. Stretching it, shrinking it, sliding it up, sliding it down, reflecting it. Heck, I don't know. So goals for the day: transform functions, understand and apply. Ooh, what's a composite function?
Something that you can put in your composite box.
Let me ask you this question.
Functional.
Have you seen this form written before? Read that as h of x. So a composite function would be something like this. What's g of h of x?
A function of a function.
Yeah, we're doing a function of a function. Composite functions are functions of a function.
What do you call a function that's a function of a function?
That would be like f of g of h of x then.
Composite cube.
Dude, I literally said that 2 seconds ago.
Third degree composite.
Sounds like Inception.
We're
Third
twins.
degree?
It sounds pretty impressive, doesn't it?
Where do you take it to the 50th degree?
That's
No.
going
Is it
fully down.
Well, you'd have to maybe use capital letters and then little letters.
No.
It gets pretty crazy. Then we start throwing Greek letters
Well,
in
you
there.
can start using ZZ.
We could. We could start using doubles. Yep, we could. That's a great observation, actually. Okay. So we're going to evaluate those composite functions also, and we're also going to describe transformations from one function to another. So I really believe you've got a background that, although you haven't talked about it much lately, I think that you've had exposure to some things. I think this will be pretty easy. Okay. Volunteer to read a transformation for me.
Any shift, stretch, or flip of an original function to form a new function.
Okay, so basically a transformation takes an original function and turns it into a what? New function. And these are the types of movements you would see. Okay. Composite function, we kind of talked about it. Want to read it, Lake?
Highlands Lake, and I'm just doing her FMU.
Whoa.
A function of a function.
Exactly. Let's see things like how do you write f of g of x or something like that. So these are the types of things you're going to see notationally that are going to be composite functions. Okay, it's a function of a function. We'll talk about what that looks like here in a little bit. Okay, odd function. This is where things get pretty goofy. Okay, odd function is odd if f of what, kids? Equals for all what? Okay, an odd function typically takes on a shape graphically like this. I'm going to do my best to sketch this. It's symmetric about the origin. I'm going to write this down over here. It's symmetric about the origin. I'm just going to write its symmetry is about the origin. And a graph for this, kids, is probably going to look like this right here. You're probably going to have some kind of an odd function that comes up through here, goes through the origin, and goes like this. Has to pass through what first, kids? Okay, it has to pass through the origin. If I would rotate that about 180 degrees, what would that graph look like? Same thing, right? It would be the same exact thing. So odd functions, when you look at them graphically, they have to pass through the origin, and then your point of rotation would be the origin. So if I made half a turn, that graph would look the same. Okay, so odd functions. Now I'll talk to you more about this algebraic sense right here, or this notational stuff here in a little bit, but understand this is what it looks like visually. Okay? How about an even function? What's it say? I really got bad stuff written here. Even function says what?
Function is even if f of negative x equals f of x for
You might
all.
want to jot this down. I screwed this up big time. Right now, f of negative x is equal to f of x for all x. And I'm going to tell you this one right here. This one here is symmetric is symmetric around the y-axis, meaning the left half mirrors the, exactly, mirrors the right half. So graphically, if I represented this graphically, this is maybe what you'd see for an even function.
What's the difference between odd and even function?
So an odd function is the highest degree of a function. Like you've got polynomials like maybe x to the 7th plus 4x to the 3rd plus x. The highest degree would be an odd number for sure. And I'm going to show you what they look like in an example.
But the equation for both of them is the same.
Not quite. This one here says f of negative x equals negative f of x for
Missed
odds.
that.
Makes sense there? And this one here is f of negative x equals positive f of x for all evens. Does that make sense there, Laker?
Yeah, I missed
Okay.
that.
Nope. Great question. Probably because it's all because I wrote it incorrectly up there. Here's an example right here. I'm doing the best to sketch it. Does the left? No, I was doing pretty good until I got there. You guys get what I'm trying to do, don't you? Oh, that's terrible. Terrible. That's my biggest mistake of the decade. Hey, anybody go to that concert Friday night?
No. I told him.
What was it, Angus Khan?
Yeah.
Oh,
Yeah, it's like Netflix.
I heard it was weird.
really? That's pretty good. Does the left half mirror the right half?
And they were like, what?
Yes.
Okay, that's kind of what we're after there, okay? All right. Just double check and make sure you have everything down vocabulary-wise before we move on to transformation rules.
If I dropped more like 6, 7,
Back there?
All right, are we good?
Yes.
All good over here? Okay. Guys, I'm not going to talk about this too much in depth here. I think that these are things that you can refer back to and apply as we go through these. Transformation rules. These are big here. All right. Might want to put a box around these and highlight them and tell them that these are pretty important. There's a few more on the next page. But kids, if you have an original function such as f of x, I don't know what f of x is. It might be a rational function, might be some kind of polynomial function, might be exponential, might be logarithmic, whatever it is. These are going to be rules right here. So guys, if I add b right here, what direction does it say it shifts? Upward. Okay, do I need to read through these or can you? You got them? Okay. And again, we've had a ton of practice with these. If you've come through college prep, if you've come through trig, you've had a lot of work with them in the past. And I think that we'll talk about just a few of these. But this is just a help you remember type thing right here. So on to the next page here, towards the top, kind of the same thing here. Were all the rules on that page? Looked like they were, wasn't it? Perfect. Okay. So let's talk here. Let's get into some examples here in terms of what are we trying to do in terms of going from an old function to a new, or in other words, transforming. Let's talk here. Example 1, writing what? New functions from what? What are we assuming f of x to equal here, kids? 3x minus 6. It says write a function g of x if f of x is translated what? Okay, so if I wanted to do this right here, if I wanted to make f of x right here, g of x is the new function we're going to make. Do you guys agree g of x equals our original function, f of x? What am I going to do to f of x, kids, if I'm moving it 4 units up? Yeah, we're just going to add 4 to the end of it. So kids, really, our g of x is going to become equal to, what function are we implying f of x is equal to? So we're going to call it 3x minus 6. That's all of f of x right there. And we're going to add 4. So what's that going to become? 3x minus what? Now guess what? I don't have this pulled up right here, but g of x would equal what here? 3x minus 2. And I think you guys know that. You've seen that, you should understand that. How can I check them all right? I can run in decimals. What can I type in first? 3x minus 6. Then type in what after that? Heck, let's go there. Let's go there. We don't, oh gosh, I hope I'm not still listening and recording music in the background.
Oh no.
It happens a lot. I make goofy mistakes. Probably the first mistake I made all decade.
No.
First one
It's just as funny as the first time.
Hey, I went to the eye doctor on the 30th and I had some problems, but he told me my vision would clear up in a few days. I have 20/20 vision now.
Hey.
I love it.
Oh, you're
Wow.
funny.
Is there any way I can like transfer classes?
Look to what?
Yes, Mom.
I break again. It doesn't
Why?
matter. Anyone but this one.
Why not this one?
Because your 20/20 vision break.
You don't like my jokes?
I don't know if I'll be able to stop laughing. I'm laughing so hard.
Oh boy, you might have to. What was the original function, kids? 3x minus 6, was that right?
Yes.
So if I go 3x minus 6 here, again, you can always check these to know if you're on the right track. Okay, there's 3x minus 6. What did we come up with after we translated 4 units up, kids? 3x minus 2. Nice. Okay, same graph, pretty much, yeah. If I picked a point here, say maybe this one. I don't want that one. How about this one? Let's see, if the red one's my original one, then 4 units up should be what point? 2 comma 0's there, so what should be up here? 2 comma what? Is it?
Yeah.
I think we're right on, don't you? Okay, so you can always check with decimals. That's a great observation. So let's do it. Let's practice a couple more. It says write h of x if what? Right? Guys, take a look at your vertical stretch rules. Am I just multiplying x by 2? Am I replacing the x with 2x? Or am I multiplying everything? What's it say to do?
Yeah. We know.
So I might choose to break this up in steps. A vertical stretch of 2 would take the original function completely and do what?
Multiply it by
So
2.
3x minus 6 would turn into what, kids? 6x minus 12. That's the first one. That's going to go ahead and stretch that vertically by a factor of 2. But then it says it gets reflected over what? Okay, so now go to your rules about reflecting over x-axis. What's it say to do? Does it say just do f of negative x or completely negate the whole function? Negative f of x. So negative the whole function. So what's going to happen to the signs here, kids? So what's this going to become? Absolutely. So in this case, h of x, after it's been vertically stretched by 2 and reflected over the x-axis, becomes negative 6x plus 12. And again, if you're not sure that, go ahead and grab it and see if that's what happened to all the points. I want you guys to try a third one on your own. Take a minute or two, see what you come up with. If you disagree, talk about why you disagree, but compare your answer on that third one. This is a tricky one.
Easy money. It's like taking candy from babies.
Some babies can be pretty scary when you're for candy.
Let's see if we all get the same answer here.
Nobody else will put it together.
Dang it.
We explained the first.
I'm gonna talk about this one. There's a lot going on here. I think the concept of horizontal stretch needs to be discussed. I think the concept of left and right needs to be discussed.
I forgot. when you said
We'll look at our rules here quickly. What was the first movement, kids?
Horizontal stretch by 3.
Okay, we need to make a note by horizontal stretches. First of all, does a value come inside of parentheses or outside of parentheses? Okay. I do not like notation with which they've written this. Okay? This should be really reciprocal. This should really be f of 1 over a times x. So it's kind of reciprocal. So it said you want a horizontal stretch of what there, kids?
3.
3. So to get something to stretch horizontally by 3, we're really not going to put 3x in there. We're really going to put what in? 1/3 x. So I'm going to write this down over on the board over here to the left, where it says, okay, what was the original function, kids?
3x minus 6.
And you might want to write this down in a box we're going to have. F of x was 3x minus 6. So that first movement was to do a horizontal stretch by what?
3.
So this is going to become f of, it's going to happen inside of parentheses right here. What was the value you wanted to use again, Maddie? Or somebody, who said it?
3.
Not 3, but
1/3.
1/3. Yeah, if you kind of reciprocate with horizontal movements are weird. You would think if I'm moving right, you would add values, wouldn't you? But you're not. You're actually doing what? Okay? Horizontals are the same when you stretch them. They kind of do the opposite of what you think. If I want to stretch it by a factor of 3, then you multiply by the reciprocal of that value. Okay? It's kind of the opposite of what you would think. Okay, so let's take this 1/3 x and replace what with that? Take this 1/3 x and substitute it in for what? Okay, so this becomes 3 times 1/3 x minus 6. Oh my gosh!
How did they cancel?
This is now to what?
X minus 6.
So we're at x minus 6, right? What does horizontal stretch mean?
You're stretching it horizontally.
Relative to what, though?
Origin.
Origin, yeah. I like that. Okay, I always tell them it's how far away the points move away from the y-axis, so that's good. Okay. Now, if that's the horizontal stretch part right here, what other part did I have left to work with then after that?
Moving right. 6
Right. Okay. Here's right. We got to do x minus our value. So now we're going to take a look. We're at this point right here, x minus 6. So we're going to look at f of x minus 6. So basically, we're to the function now, x minus 6. So what are you going to replace x with now to make the right movement? Yeah, you would replace the x with x minus 6. So this becomes, isn't that what it becomes there?
Wait, can we talk about how it's already been 20 minutes? How are they already back? It seems like it's been like 5 minutes.
I know. Goes fast, doesn't it?
Time goes by faster than it goes.
So what do I end up with here, kids? X minus 12. Could I check this stuff?
Graph it.
Should we graph it? Let's see what we get. Let's talk about this graphically.
Bryson,
Yeah!
I'm confused. Why did you change it to x minus 6?
Because the next step was to go what direction?
Yeah. You had x minus 6 and you
Okay.
add another.
Let me ask you the first question. Let me back up here real quickly. Do you understand how, by the horizontal stretch, when I plug 1/3 x in, when I plug that in for this, 3 times 1/3 x became x minus 6, right?
Yeah.
So it's kind of like we're breaking this down into steps. So the first step was to do the horizontal stretch. This is where we're at now. We're at x minus 6. And then the second step says once you've done that horizontal stretch by 3, then you got to move right 6. So you're going to replace it.
Yeah.
It just happened that both 6s probably threw you.
Happy birthday.
Thank you. So what do we end up with? X minus 12, right?
So you know how they're gonna do it next?
San Francisco.
I have some Niners that are gonna say.
That'll be a tough one.
But also, we never thought they would win this way.
So true story, 1988. I know I'm off task and I'm recording this, but true story, 1988. The Vikings were kind of a mediocre team like they were this year. Guess who they had to play in the first round? At New Orleans, went down there, won 44-10. Then they had to go play the number 1 seed, San Francisco, the week after. Went out there and won. So we might see a little bit of history repeating itself. Wouldn't that be cool if it does? I thought I was going to have a hard time teaching today because there was a point yesterday where my voice was kind of going a little bit. I was yelling. And I was excited yesterday. It was good. Plus, I had my Kyle Rudolph jersey on, and guess who caught the game-winning touchdown?
I think
Rudy.
Adam Thielen did the game winning.
Well, he was good. He was good, but Rudy's my guy. He's a good guy. You know why I like him so much? He has a huge amount of his salary that goes to donation to the Masonic Temple up there, the Children's Hospital at University of Minnesota. He is so good about that. Okay, let's graph this puppy. What did we start with originally, kids?
3x minus 6.
So there's my 3x minus 6. What did we come up with? X minus 12?
Yeah.
I'm going to pick on some points here, kids. I'm going to pick on some points. Let's do this point right here, 0, 2. How far away from the origin is 0, 2? Okay, so that point should be stretched away how many points? Should be stretched by 3. So it should be, what's 3 times that distance of 2 from the origin? Okay, I'm going to put in the x minus 6 part here. Here's the x minus 6 part. Did this point get stretched 3 units? Is that a horizontal stretch of 3 right there first? To go from red to purple? And then we need to, after that, move what direction? Right, how many units? Here's a horizontal stretch in purple. Now, let's see, if this is 6, 0, then moving this to the right 6 would make this what point? Is that what happens? Okay. Guys, we're going to start talking about composite functions, but how many transformations were involved in starting from here to get to here? 1, 2. So do you understand why I have an original? First transformation is that stretch. What we end up with finally is this line, x minus 12. Was it first of all stretched horizontally 3 units to get to 6, 0? And then from there, was it moved over to the right? Let's pick a different point. How about this point right here? Doesn't this point look like 1, -3 right here? Quick question. If I stretch this by a factor of 3, 1 should turn into what? 3. And then 3 to the right of that should turn into what? Does it? Looks like x minus 12 is right, isn't it? Okay. All right. Did anybody have x minus 12? That's a tough one. How many are on board with x minus 12 right now? Maybe that's the better question. Are you with me on that now?
I got f of x equals x. That's my problem. I was silly.
You were thinking +6, were you, for right? But you're on the right track. Those rules, they'll come back to you quickly. But I would say that part that we highlighted, just have that in front of you as you're going through problems like that, okay? Question, John.
What if it had been like 3 1/4, 3 1/4 x instead of 3 1/3 x? Because the 3 and the 1/3 they cancel out, and then you're just left with x.
So what if they would have said stretch by 4?
Yeah.
So if I would have said stretch, well, what was it? What was the original? 3x minus 6, John?
Yeah.
So if I would have said stretch by 4, it would have been f of, you're talking horizontally, right?
Yeah.
1/4 x, yep. So this would have become, if I plug this in, this becomes 3/4 x now, doesn't it?
Yeah. Oh.
Yep. Slater,
Yeah,
need me quick?
real quick, come here.
Yeah. Read on to example 2 for me. See what's going on. Is there an example 2 there?
Yeah.
Okay. I'll be right with you. Read what's going on there. Where you at?
Wait, wouldn't that 3 make it?
What
Ah.
I hate that. I don't want to cover it. There's like.
Guys, what do you think? Find f g x is. I think it's.
Impossible.
I think it's gonna be x squared to the x plus 6, and you have to freaking factorial.
Okay.
No.
Let's talk about what's in example 2 here quickly.
What happened?
So, is this part that gets into composite functions? Is that right?
Yeah.
Okay. I want to make a note about this. Anybody remember how to do these?
Don't you?
Foil?
Have we done this?
Kind of. You've done this a little bit. I don't think that we do a very good job of getting into it at times, but I think that you'll understand totally. Okay? It says writing what first?
Chicken butt.
Composite functions, where Lake said a composite function is a function of a function. Okay, so here's the deal. What are we letting f of x equal here?
X squared.
G of x is,
Natural log of x plus 6.
and h of x is.
4x minus 2.
So they say, hey, we would like to write a function that's a composite of f and what? Okay, what this is saying is this. Now, anytime you write composite functions, you always, and make a note up here, this is important, start with the innermost function. Start with the innermost function.
Mm-hmm.
Okay, are you there? Start with the innermost function. Now, guys, when I look at this first example that we're about to do, it says find what?
F of g of x.
Okay, so am I starting with f, g, or h?
G.
Starting with g. So guys, this really becomes the following. This really becomes f of, well, what the heck is g of x equal to, kids?
X was
Natural log of x plus 6.
Okay? So this becomes the natural log of x plus 6. F of the natural log of x plus 6. So what this is saying, kids, is this. Our outermost function f is what we're going to end up with. And it's saying, okay, well, f of x is equal to what here, kids? Say where you have x in your function f of x, replace it with what?
X squared.
All I'm doing is taking this part right here, g of x. We're taking this whole function g of x and replacing the x here in our function f. So this is going to become the following. F is equal to x squared, right? So this x is going to get replaced with this whole function g, natural log of what?
X plus 6.
So this f of x is going to, f of g of x is going to equal the following. It's going to equal, okay, what am I replacing x with? Natural log of x plus 6 all to what power?
Now g.
There it is. Okay? You guys try g of h of x. I want to see what you come up with. Where are you starting with?
So that's the answer now.
Mhm.
Why is the square on the outside?
Because this natural log of x plus 6 is everything that replaced this x right here that I'm pointing at.
G of h of x.
Oh.
Basically, I'm taking this mess right here,
Oh.
and this mess is going to replace every x in that function right there.
Okay.
You okay with that?
Yeah.
Okay. So, what's h of x equal to? 4x minus 2. So in g, everywhere where there's an x, it's going to become what?
So it's just.
Wow, this next one is kind of hurting my brain.
Yeah, and it should.
This winter, I still have winter break brain.
Here we go. On this middle one, I'm taking 4x minus 2 right here and plugging it in where?
to g of the x and g of x.
Okay, so this is going to become the natural log. Do you guys agree that for g of h of x, I'm taking this 4x minus 2 and putting it in where?
For x.
X, right there. You guys agree there? So this is going to become a natural log of 4x minus 2 plus what?
6.
Okay, do I want to leave it that way or maybe simplify it a little bit?
Simplify.
So this is going to become a natural log of what now?
Plus
4x plus what?
4.
There you go. Okay.
Wouldn't it be,
It's negative 2 plus 6.
wouldn't it be 5x?
No? No, because this whole x right here, anywhere where there's an x right here, I'm just simply replacing it with this whole function, 4x minus 2. So I basically took this x and replaced it with what?
4x.
Okay, let's try this next one together. I think this next one together is going to be kind of tough, so let's do this one together. You guys are going to talk me through it, though. Hang on, where are my tools? Okay, well, what function am I starting with here, kids?
Oh my goodness. H.
Okay, how many composites do we have here? 3 of them, right? So the first thing I need to do is put f of x in for what? So we got to plug that in for g. So this, the g of f of x part would say take x squared and plug it in where first?
G.
Okay, so the first one, we're up to a natural log of what now first? By these two. We're plugging f into g. So x plus 6 will become what?
The natural log of x squared plus 6.
I think I got it. Show us the answer.
All right, first things first. You guys agree with my first two innermost?
Yes.
You agree with that first step?
Yeah.
Okay, now what's going to happen?
Throw the 4 in there and minus 2 and then.
We're going to take h
And put it in
and put it into what we have here now, right? So this will become a natural log. This is going to get kind of ugly. That's okay.
4x 2. What? No.
Right?
No.
What?
Yep.
Yes.
Where'd the x
I don't
go?
know how you got it.
Hey, f of x is going into what? Okay.
Oh, yeah, I have a question.
No.
So f of x is right here, right?
Why is 4?
Do you guys agree with the first one? F going into g becomes natural log of x squared plus 6. You agree with that step?
Yeah, I have a question.
Okay, so that's where we're at now, right?
Why do we just throw all these
Yes.
x's around?
Because we're just substituting functions for x. Now, where there's an x right here,
Alrighty.
to come back to h, what do I have to throw in for x now?
4x minus 2.
Mm-hmm. Isn't that what I just threw in for x right here?
Yes.
Right? Let's have you try one and end on a good note. Go to a blank sheet of paper. Is there a blank side on the notes anywhere?
Yeah.
That last page blank. Go there. You guys try this.
No, you.
You guys try g of... let's try this one. H of f of x. You guys try that one. So you're throwing what into what first? F into h, right? Whatever that is. Oh, wait a minute. Did I screw up?
No.
I did. I did screw up.
Isn't it
I understood
on the outside?
Yeah, because
I messed that up. We need to go back.
you take
I
whatever.
totally messed that up, you guys. I'm going to have to edit that part. Let me clean that up. I totally messed that up. Ugh.
I was gonna be awesome though.
All right, we got A. Let's put F back in here, kids. Help me out. Put F back in. what did we have? I got myself
It's
confused now.
natural log of
Natural log of x squared plus what?
6.
Alright, I totally screwed this up. Okay? That's this inside part right here now, isn't it? Now we need to take this mess and put it in for what? Into h, right? Right where there's an x, I screwed this up. So right here where this x is at now, what should I put in there? That one. Alright, that's better. 4 natural log. I messed that up. My bad. So you see what I'm doing here? This was g of f of x right here. Now I need to take this and put it in here. I was doing it the opposite way, wasn't I? I was putting h in for what we have. My bad. What should be at the very end?
-2.
-2. How many had that originally? Oh, good. I see why you guys, I was like, something's not right, and I messed it up.
To be completely honest, I did not have that written in this.
That's okay. You know what? I think that's a good place to stop. We'll pick